Okay, harmonic sequence. So we have 1 over a sub 1, 1 over a sub 2, 1 over a sub 3 is called a harmonic sequence. Let's try number 1. We need to find the 7th term of the harmonic sequence. So disregard this numerator. We will start with the denominator 2, 6, and 10. So since we are looking for the 7th term, we have to find what type of series is the denominator. If it is arithmetic, it is geometric. So 7th, let us try. These are all arithmetic actually. And the reciprocals of this arithmetic sequence, 7th term. So what's the difference between 2, 6, 6 and 2, 10 and 6? So the difference is 4, right? So difference is 4. So that is the common difference. What is now what's now our formula that you're going to use? What's the formula that we are going to use? We have a sub n is equal to a sub 1 plus n minus 1 times d. So since you're looking for the 7th term, so a sub 7 is equal to a1. We have a1 which is 2 plus n which is 7 minus 1 times the common difference which is 4. So therefore, we have a sub 7 is equal to 2 plus 7 minus 1 is 6 times 4. So 2 plus 24, which is equal to 26. So that is a sub 7. So meaning to say that our 7th term here is 1 over 26. So this is the final answer that we are looking for. 1 over 26. Okay? Now, let's go to number 2. Find the 15th term of the harmonic sequence. So we have letter B. 10, 14, 18, and 22. Right? So what is the common difference? So it increases by 4, right? So this also 4. So since we are looking for the 15th term, so we have to use the formula a sub 15 is equal to a1. Our a1 is 10 plus n is 15 minus 1 times the common difference, which is 4. So therefore, we have 10 plus 14 times 4. So 10 plus 14 times 4, which you will get 40 plus 16, it's 56. So therefore, we have 66. So our 15th term is 1 over 66. You got it? So we just only use our formula for finding the nth term of the arithmetic sequence. Okay? I'll try to get this. Okay, so I will be getting another. I can screenshot. Wait. I need to get the screenshot of this. Number 2. Okay, so when we have the next example like this, the nth term of the harmonic sequence. So in the harmonic sequence 1, 3, 1 over 3, 8 over 1 over 8, 1 over 13, 1 over 18. Which term is 1 over 1, 2, 3? So let's try which term is that. So what we're going to do, will be, so letter A. Looking for the n, right? So we have 3, 8, 13, 18, and 123. So what's the common difference that they use here? 5, 5, 5. So the common difference is 5. So we are looking for the nth term. So the nth term, since our a sub 1 is 3. So again, our formula that we are going to use is a sub n, a1, and minus 1 times the common difference. So a sub n is equal to 123, a1, which is 3, plus n is the unknown, and the common difference is 5. Right? So 123 minus 3 equals, you distribute the 5n minus 5. So 120 then plus 5 is equal to 5n. So we will have 125. 5n is equal to 125 divided by 5. So n is 25. So meaning, which term is 1 over 20? So the 25th term, right? Is the 25th term. Okay? So next, on letter B, find the first term of the harmonic sequence, which the fifth term is 1 over 28, and which the 30th term is 1. 30th term is 1 over 178. So let's go to letter B. Letter B, we are looking for the first term, a sub 1. Okay? So since we have 28, 28 is the fifth term. And then we have 178 is our nth term. Right? So this is the fifth term. This is the 30th. Okay? So if you will consider the fifth term as a sub 1, what would be the 170th? We will move 5 backwards, right? So instead of, we will be writing here, the 28 will be going there, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Before it was here, right? So we will move how many times? 1, 2, 3, 4. Before it was a sub 5. Then we moved how many times? 4 times. So it became what? A sub 1 as the first number. Now, if we will try to move the 130, the 30th, what would be the position of the 30th now? We will move 4 times also. So let us go to 30. Yes, 30, 29, 28, 27, 26, 25. This is the 30th, right? This is 178. Now, if we will move this going to the left, as the same as we move the 28 as the first number, so we will move also 4 times. 1, 2, 3, 4. So it means that the 178 is on the 26th number. Correct? So, Adrian, why are you laughing? All right, so let us go back to our formula. A sub n is equal to A1 plus n minus 1 times the common difference. So what is A sub n? We have the 178 is equal to A1. We consider the A1 as 28 plus n. The n is we don't know. The n is on the 26. The common difference that we are looking for times the common difference. So then 178 minus 28 is equal to 25D. So 178 minus 28 is 150 equals 25D. Divide by 25. So what is the value? 6, right? So the common difference is 6. So can we get our first term now? A1, A2, A3, A4, A5. Our A sub 5 is 28. JL, what is the next number, A sub 4? If our common difference is 6. JL.
22.
22. Next, what's the next number? Adrian, what's the next number?
16.
Huh? 16, then?
10.
Then?
4.
4. So our first number is A sub 1. Since it is harmonic sequence, it is 1 over 4. Okay? Did you get it? So we move the number so that it's easier for you to do it. Or we can create also an equation and we can use simultaneous equations. Okay? Now let us proceed to the next one. So here they use simultaneous equations to solve this, okay? So now what do we mean by harmonic mean? Okay, we'll try this first. Okay, I'll try to do that first. I'll get a copy of this. Okay, what is our 12th term? Can we solve? On letter A, what is the answer? So we have 3, 7, 11, 15. What is the common difference? It is 4, right? So the common difference is 4. So we have A sub 12 is equal to 3 plus 12 minus 1 times 4. So 3 plus 11 times 4. So 3 plus 44, which you will get 37. That is A sub 12. So now we are getting the 12th term of the harmonic sequence. You have to put only 1 over 37, the reciprocal of the number. So letter B.
Sir,
Sir, it's
Ah,
47
47
po.
po.
47. Thank you. And that's 47. Great. Okay, next. What about B? B is 1 over 99. Which term is 1 over 99? So let us do 99 as the JL. What's the answer? Letter B. Are you playing?
25, sir.
Huh? Okay, so we have
Sir, my
99
answer
is
is
equal
23.
to 3 plus n minus 1 times 4. So 99 minus 3 equals 4n minus 4. So 93 plus 4, 96 plus 4 is equal to 4n. So 100 equals 4n. So divide by 4. So n is 25. So this is the 25th term, right? Okay. So it's easy because we just repeated our lesson. Now, we have the harmonic mean. The harmonic mean formula is this. A and B are two positive numbers, then the harmonic mean of A and B is given by this equation or formula. 2AB over A plus B. All right? If there are three, this is the formula. Okay? So let's start. Find the harmonic mean of 24 and 12. So we have 24 and 12, the harmonic mean, we have the formula H is equal to 2AB. So 2 times 24 times 12 over A plus B. So 24 plus 12. So get the answer on your calculator, then you can get the harmonic mean. So what is the value? So 2 times 20, so 2 times 24 times 12 first, which is 576 over 24 plus 12, 36. So 576 divided by 36 equals 16. Okay, next letter B. Letter B, we have this formula, 3MNP. So MNP. So we have 3 times 3 times 4 times 5. Then you have to get the product of NP. So 4 times 5 plus MP. MP. So 3 times 5 plus MN. 3 times 4. So 3 times 3 times 4 times 5. 180. divided by 20 plus 15 plus 12. So 47. So 180 divided by 47 equals 3.8. 3.83. Okay? So that's harmonic mean. Don't forget the formula. 2AB plus A plus B, or 3MNP plus NP plus MP plus MN. That's harmonic means. Okay, let's go to Fibonacci sequence. So a Fibonacci sequence is a sequence that which its general term is given by this formula. Okay, so let us try 1, 1, 2, 3, 5, 8, 13, so on. So it adds 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. Okay, it's not actually written on your...
Sir, what are the numbers pa again?
Just wait, fifth. So let us try this Fibonacci sequence. Terms. Like, look at these terms. We have on 1 plus 1, you will get 2. 1 plus 2, you will get 3. 2 plus 3, you will get 5. 3 plus 5, you will get 8. 5 plus 8, you will get 13. 13 plus 8, 21. And so on. Right? So that is a Fibonacci by adding the two previous terms. So in general terms, the Fibonacci sequence has this formula. Fn minus 1 plus Fn minus 2, or n is greater than 2, where f of 1 and f of 2 are given by the Fibonacci sequence corresponds to f1, f2, f. Okay, it's equal to 1. So let us try the Fibonacci sequence example. If f1 and f2 represent any numbers of any first numbers, list the first terms of this Fibonacci sequence type. Okay. And given if f sub 16 is 987, f sub 17 is 1597, what is the value of f sub 18? So look, f1, f2 represent any first numbers. Okay. List down the first terms. So the first is actually f1 and f2. Okay. So when we get the f3, isn't it that you are going to add these two? Right? So f sub 3 minus f sub 1 plus f sub 2. Now, to get the f sub 4, to get the f sub 4, we will have f sub 3 plus f sub 2, where f sub 2 to be added by f sub 1 plus f sub 2 again, and so on. So this longer, it will just give you a confusion how to write this f, a lot of f. Look. And on letter B, we have, if f sub 16 is 987, f sub 17 is 1597, what's the value of f sub 18? So let us try to do this. They are just consecutive, right? 16, 17, and 18. 987. So in order for you to get that to f sub 18, you just only add these two, right? So 1597 plus 987, which you will get 2587, right? Just only add the two previous numbers. What are the two previous numbers? 987 and 1597. You got it? Okay, next. Find the sum of the squares of the first n Fibonacci numbers. 1, 2, 3, 4, 5, 6. Examine the pattern and generalize the relationships obtained. Find the sum of the squares of the first n Fibonacci numbers. The sum of the squares. So what does it mean by that? So let us try to get on that copy. So what are those sum of the squares? So 1 squared equals 1. So what would be the value? Find the sum of the squares of the first Fibonacci numbers for n equals 1, 2, 3, and 4. So examine. What is the first? What are the numbers? 1, 1, 2, 3, 5, right? 1, 1, 2, 3, 5. First square. Then here, square, square. This n equals 1. N equals 2. N equals 3. N equals 4. And n equals 5. So 1. So what's the next one? 1 squared plus 1 squared plus 2 squared. Next, 1 squared plus 1 squared plus 2 squared plus 3 squared. The n is 4. 1, 2, 3, 4. Here, the next one, we have 5 numbers. 1 squared plus 1 squared plus 2 squared plus 3 squared plus 5 squared. So this is 1. This is 2. 1 plus 1 plus 4 is 6. 1 plus 1 plus 4 plus 9, right? 1 plus 1, so this is 4, 6 plus 9 is 15. And then there's until 6. 1, 1, 1. So these are 6. 15 plus 25, you will get, what's the value? 40. Now, we have also 6 and sub 6. So 1 squared plus 1 squared plus 2 squared plus 3 squared plus 5 squared plus 8 squared. So what is the value? Here it's already 40. 40 plus 64 is how many? It's 104. Right? Okay, what have you noticed about that? Okay, it's like this. Can you have 1 times 1, 1 times 2, then 2 times 3, then 3 times 5, then 5 times 8, and then 8 times 13 times what? 13 times 8, 80 and 24. Right? Look, 1 times 1 is 1. 1 times 2 is 2. 2 times 3 is 6. 3 times 5 is 15. Because we got that 5 to the sum of 2 plus 3. Here 3 plus 5 is 8. And then you multiply by 5 that number. And then 5 plus 8 is 13. Multiply that by 8. Right? So we can have our value as sum also of the previous, but we are going to multiply. Okay. Right? So that is also an
So when the
observation.
parabola is opens upward, also downwards, right or left. So when it is x squared, you are expecting that the parabola opens downward, right? When it is y squared, it is right or left. But if it is positive, it opens to the right. So you have the formula that I summarized over here. They're all here. So the given question number 1 is x squared is equal to negative 10y. So which case you are going to use on this question? So as you can see, it's in this form. So it is on case 2, right? So therefore, we are going to get what? The vertex. Definitely the vertex is in the origin. We need the focus, equation of the directrix, principal axis, and the endpoints of the latus rectum. So let's start getting first. In order for you to get the focus, you have to get first the value of the P. Okay, let's start. This is negative 10. So the equation that we are going to use is on case 2. X squared equals negative 4py. So we will equate this to negative 4p is equal to negative 10. So we'll divide both sides by negative 4. So p will become equal to 2.5. That's your p. So we got the p, we can get our focus, right? So the focus is on 0, negative p. So definitely you have that p, so your focus is 0, negative 2.5. Okay? And you have the directrix equation of the directrix y equals p. So y equals the value of the p, which is 2.5. And the principal axis definitely is on the x is equal to 0, but we need to get the lattice rectum endpoint. So we have negative 2p, p, and 2p, p. So that's our equation or formula for lattice rectum. So we will substitute the value of the p. So negative 2 times 2.5 and 2.5. Also, we have 2p, 2 times 2.5 times the p, which is 2.5. So therefore, we have negative 5 and 2.5, 5 and 2.5. So let us now graph. So we have the focus, we have already the directrix, we have the lattice rectum. Okay, so let us graph now. We have to insert the graphing text. I mean insert media calculus. Okay, let us graph this. The focus is located on 0, negative 2.5. 0, negative 2.5. So where is that? It's here, negative 2.5. 0, negative 2.5. The lattice rectum endpoints negative 5 and 2.5. And why it's not on the third quadrant? RP is 2.5, right? We have negative p. Our formula is negative p and negative also. Okay, so therefore we have the value. So what happened to this? So the value of this is negative 5, negative 2.5, and 5 and negative 2.5. And this is our vertex. So the parabola opens downwards. Okay, so this is our lattice rectum. And our directrix is opposite of the focus, so it's over here. So y is equal to 2.5. This is the directrix. Okay, clear? That is all about the first. Now we have the second one. Y squared equals 12x. Okay, so which case is that? So I'll be deleting this first. Which case is the given on number 2? So as you can see, it is on the y squared. So you are expecting that the parabola is either opens to the right or opens to the left. But since it is positive, so we are expecting that the parabola is going or facing to the right, opens to the right. Okay, so that is on case
3. Okay, so y squared is equal to 4px. And then the given is y squared is equal to 12x. So you know what to do? You just equate this to 4p and 12 to get the p. So 4p is equal to 12. Did we use p on the previous one or c? Okay, so we'll divide by 4 by 4. So p is equal to 3. Okay? So therefore, we will identify our what? We identify our focus, our directrix, our principal axis, and the endpoints of the lattice rectum. So the focus is at P0. So the focus now is at 3, 0. Our directrix is x is equal to -3, the opposite of that P. And what about our endpoints of the lattice rectum? Lattice rectum will be P, 2P, and P, -2P. So the P is 3, 2P is 6, 3 and -6. So we can graph now our parabola. So actually this is a little bit easy because we have already the formulas. So the parabola opens to the right. So we will just start with the focus first. And then let's continue. So 3, 0, 1, 2, 3. So this is the focus at 3, 0. Next we have 3, 6. 3, 6. 3 and 6. This is the lattice rectum endpoints. And the other one is 3, -6. 3, -6. So this is 3, -6. And then this is our vertex. And our directrix is at -3. So it's over here. So this is our parabola. So let us connect the points. All right. And our lattice rectum is over here. This is y is equal to 12x, y squared. Question? Do you have any question?
No po, sir.
Okay.
Can I see the cases po up, sir? Yung mga cases po, sir.
Here,
Yes, sir. Like,
case one case.
sige po, sir.
Take a picture.
And also the next, sir.
Wait, I'll
Can I see?
remove the color.
Ay, sige po, sir. Take your time, sir.
And also the other one. We used also P as your focus. Ali, do you remember? Or C? We use C.
P, we use P.
P, okay, great. Okay, take the picture and also on the right side. Okay, just case one, case two, case two. So you know if it is what case it is, okay? And the parabola when the vertex is 0, 0. What about this?
The other side, sir.
Sir, can you
Okay, take a picture.
Go down, sir.
Go down. Wait, they are taking a picture first.
Okay, sure. Later, sir.
It's done here. Okay,
Yes po, na-screenshot na
Yes,
po.
sir.
Okay.
Thank you, sir.
What about this, Justin?
Sir, paulit po ulit, sir.
The upper part? This.
Done, sir.
Here.
Okay, so you know what to do, huh, with this. Okay, now let's go with the one with number 9 and number 10. Number 9 and number 10. So we have to take care of 9 and 10 because they are on other cases. Okay, so when we have this, let's start with number 9. Number 9, I'll write number 9 and I'll erase first this. So this is, now we will be using the next cases from 5 to 8. Okay, so when the vertex is on HK, so we have the given is y equals, oh, it's green. Y equals this number 9. 1 over 8 x minus 8 to the power of 2 plus 2, right? Okay. So when we have this, we will be having in a general form. So make sure that we will be checking our equation on these forms. So as you can see that the squared is the x. So it's either case 5 or case 6, right? So let us try to first multiply, or we will move the 2 to the left side, or we can move this and there. Okay, let us see. This to be moved on the left, this y to be moved on the right. So it will become positive 1 over 8 x minus 8 squared equals negative y plus 2. Now we will multiply both sides by 8 so that the 8 will be cancelled as denominator. Cancel. So x minus 8 squared equals negative 8 open bracket y minus 2. Why is it minus 2? Because we factored it out. Okay. So now which case that you can see is number 9 on our formula? Which case it's suitable?
Number 6 po, sir.
Okay, number 6 because it is negative, right? So now we have the vertex, the focus, equation of the directrix, principal axis, and then the endpoints. So we will be copying that formula because it is x minus h squared. During our time, my board is not working well. Squared equals negative 4p y minus k. Okay. So let us have our negative 8. So these are to be equated. All right. So it will become negative 8 equals negative 4p. So we will divide our p both sides by negative 4. So the value of p is 2. Right? So this is the h. What is the h value? It is 8. What is the k value? It is 2. So what is our formula for focus? HK minus P. HK minus P. Do we have all of those given? Yes, we have. So we will be getting our focus. The focus should be on H and K minus P. Focus. H and K minus P. So what is our H? It is 8. What is our K? K is 2 minus P, so 0. Okay? That is our focus because the K is 2, and then the P is 2. 2 minus 2 is 0. Now let's go to equation of the directrix. Y equals K plus P. What is our K value? 2. What is our P? 2. So the directrix is at 4. Now we have also this endpoints. So the endpoints is H plus 2P and K minus P. So H plus 2P. So what is H plus 2P? H is 8 plus 2P. 8 plus 2P. So what would be the value? 8, the P is 4. So 4 plus 8, so should be 12. And comma, the value is K minus P. K minus P, so 0. And then the other one, H minus 2P, so H8 minus 2P, so 4. And then K minus P is also 0. So these are the important things that we need. Then we can graph now. Because I need to change my... Okay. So what is our focus? Is this opens upward, downward, or right, left? What's our focus? The focus is at 8, 0. 8, 0. Now we have vertex is at 8, HK, 8, 2. 8 and 2. And then our lattice rectum 12, 0, 12, 0. And 4, 0. 9, 10, 11. So it's over here. And our directrix is at 4. It's here, 4. This is our directrix. Now we will graph this one. This is our parabola. The focus and the vertex. The vertex is at 8, 2. Did you get this point?